What's that? Look at that. It's very good installation. Comfortable. And there's more. Hey, that's very funny. We are installing a treetop camping. Oh, rain is coming. Rain is coming. Look at that. This is the wood bowl. The wood bowl, like Jean-Luc Blanc. It's amazing. It's like the head of the marsupilami. And the inauguration will be day 28 for the ones who want to come in Belgium. And this is an experimental site.
Inverse procedural modelling of tree models, that is, finding the generation parameters for a given geometry. In general, this is a complex problem. However, by restricting ourselves to branching structures, we find an efficient approximate mechanism. Our method allows us to automatically convert existing tree models into a procedural representation of their species that can be used to create visually similar models of the analysed trees. The input of our method involves 3D models from a wide variety of sources, created using tree modelling tools, grown virtually using biologically based systems, or reconstructed from 3D data. The obtained trees often look very realistic, but once they are created, the models are static. Using these models to assemble forest scenes produces unconvincing results of low visual quality. Each tree would have to be modelled manually according to its environment. One way to create many different trees interacting with their environment is to use a developmental model that simulates the tree growth. We use a developmental model that is controlled by a wide range of input parameters that control the growth process. By changing the parameters, our model allows us to generate a large variety of trees from different species. And it is easy to integrate the tree models via their defining parameters. However, it is extremely difficult to manually select parameter values that would produce trees similar to the input. The aim of our approach is to automatically find a set of parameters that would generate stochastically similar output trees for a given input. We achieve this goal through optimization, traversing the parameter space and maximizing a similarity measure between the input tree and the trees generated by the developmental model. When the parameters are found, the input tree can be stochastically reproduced and even regrown in a new environment. The representation of the input tree by a set of parameters for a growth model is a very effective data compression of the input. This scene shows various trees that have been reproduced from X-form models. Here is a similar scene, but only showing tree models that are reconstructed from laser-scanned point sets using Livni et al.'s method. The third scene only shows trees that have been grown using open L systems. Here we show an artificial scene filled with unique instances of the same tree species reconstructed from a single input model. The trees show visual variety, but still resemble the input. They also interact with each other and with obstacles in their environment. The input trees would need several gigabytes of memory space. However, in our representation, each tree requires only a few hundred bytes. Here is another scene, but filled with trees of various species that have also been generated using our approach.
Trees. Hopefully you can see the fruit on it. Lots of cherries. This means cherry wine later in the year. Alright, swinging around. This one doesn't have a lot of cherries on it. It's got a few. And this one has lots of cherries. So these four have a pretty good amount of cherries. And then on the other side of the yard there's one more that's not quite as fruitful as these. As you can see, I had some disease earlier in the year, and I'm not sure. These came from Arbor Day people. And I have had nothing but bad luck with trees that I've got from the Arbor Foundation. So my concern is that these cherry trees are diseased and will die within a season or so. And that's what I've seen from Arbor Day Foundation. And the trees either come mislabeled, or you can see and it's not like I mean, I am a very successful gardener, so and you can tell this is diseased too, because of the way it's striking the tree. So anyway, but we're gonna have cherry, at least one year we're gonna have cherry wine.